So now the topic is safety procedures. Safety procedures are essential anywhere. And if you've ever been on an airplane, the first thing that they do once you're seated in the airplane before it flies, what do they do? They give you a safety briefing, right?
Yes.
Right. So that safety briefing is a part of a safety procedures, so that everybody knows what to do when things happen. So it is essential that safety briefings are given. So even in our university, in faculty, whenever we have visitors coming in, if you remember when we have when you have other people coming in, we have to always start the event with a safety briefing. So we tell them what to do when there's a fire alarm, or what is the fire escape route. And these are also, you have all these posters pasted around the buildings too. You will see, oh, this is where you are, and this is the fire escape route, and where you should go, right? I'm sure you have seen those things. So those are part of safety procedures. So not just those briefings and posters, things like these warning signs or stickers. You put this as a precaution, as a warning for people who are around the area, so that they can be careful of the hazards that is near them. Okay. So process safety, the strategies are, firstly, they are the inherent strategies. Okay, the essential one. The essential one is we have to try to eliminate completely. Okay, you identify what are the hazards. Okay, and think about ways of how you can completely eliminate the hazard. Or if you cannot do that, try to significantly reduce the hazard. Okay, so it's prevention. It's always prevention is the best thing to do. Okay, rather than try to have add-on protective systems and procedures. Okay, try to eliminate them first. Okay, and then. But you still need to put on protective systems. You can have a passive or an active protective system or procedure. A passive system is a safety features that do not require action by any devices. For example, putting on a wall, putting on safeguards. Okay? Those are passive features. You do not need to have any action by that device or anyone. It just stops. It just restrains somebody from doing something bad, okay, or something bad getting to you. That's a passive safety strategies. An active safety strategy is, for example, you have a safety shutdown system to prevent accidents. When an operation exceeds its limit, for example, so you can have an automatic system that shuts down the system, it shuts off the system so that you can prevent further accidents from happening. And then there's also the procedural process safety strategies. This includes that safety briefings on the airplane, so safety briefings that you give to visitors. So you give them what are the standard operating procedures, also standard operating procedures for operating a machine, and then what are the safety rules that people must comply, and then trainings, giving trainings to operators to give them trainings of new skills, or if you have new workers, you provide them with trainings. And you also need to have an emergency response procedure. That's why you always do routine fire drills, so that you understand how to respond to these emergencies. And then also management techniques too. All right, layers of protection. We've seen this before. We've talked about this before. So let me just recap here. The layers of protection that you can have. Okay, let's say just from so one vessel, for example, if you have a reactor. Okay, if you have a reactor, first of all, the protection starts way before you even have that reactor. It starts from the process design. When you start designing that reactor, you always put in all these threshold limits. What's the limit of the pressure? What's the strength of the material? How high can it withstand high temperature or freezing temperature? What sort of chemical can you use with it? What should be the level that's allowable in that vessel or in that reactor? So those are already a layer of protection at the process design level. Okay, and once you have that reactor installed, you must have a process control. A process control is a second layer of protection where you put in all these instrumentations, such as valves, all the safety valves, okay, that automatically opens and closes, and then you have sensors such as flow sensors, flow indicators, temperature indicators, temperature sensors, pressure, and so on. And those these sensors, they have its you set its limit, and if it exceeds the limit, then it will automatically open a valve or shut off a system or valve, and so on. So if it exceeds the limit, then the next layer of protection is to have an alarm system. So alarm system would then create awareness to the operator to start intervention. Okay, so this is operator intervention when he has to do what he has to respond to it, whether he has to evacuate or he has to shut off the process, or whatever to prevent accidents, for the accident. And if it still exceeds, if the accident still happen, okay, so you can have a safety instrumented system. You can trip the overall plant, the overall system, and then if accident happens, let's say you have a leak in that vessel, or an overload of the vessel with whatever chemicals that's in there, it can cause increase in the pressure. Once the pressure increase, it can cause the vessel, the material, the shell of the material to burst or leak. Or when you have, so you want to stop from having that overpressure, so you can have active protection systems such as a rupture disc or relief valve, so that you can relieve all that pressure, so that you don't so that you prevent that vessel from exploding. So you have that rupture disc. If you remember that demonstration about the Blavie demonstration, when you have that tank and it's being heated and it causes the rise in pressure in that tank, so it has that rupture disc. So the rupture disc release the pressure, so that you don't have that increase of pressure in the tank. Okay. So if that doesn't work, you still have that fire, you can have a passive protection system such as the bunt or the dike. You can have an enclosure. That's why all these operations, they're normally in an enclosed space. You have walls around it, so that works as a passive protection system, so that you don't you can restrict the fire from spreading. And of course, you need to have a plant emergency response, where the fire brigade, police, ambulance, they have to respond to it, and then as well as community emergency response. So those are the layers of protection, and we've also seen it's sometimes showed as the an onion that's cut in half. You have all those layers. Okay, operating procedures. Operating limits, such as for startup, for shutdown, or for normal operation and emergency procedures. These are crucial, and the procedures, not just for operating limits, it should also include and highlight what are the consequences if the limits is exceeded. Okay, show them what sorts of accident can happen. Learn from mistakes, and it's always good to not just learn from your own mistakes, but to also learn from other people's mistakes. Look at other mistakes, other accidents that have happened elsewhere. Include corrective actions or steps to avoid deviations from the normal conditions. So they should have steps on how to avoid this. Now, there's also permit procedures. So we talked about operating procedures. So now there's permit procedures. So permit procedures is a specific procedures that's required to control non-routine activities that are conducted in potentially hazardous environment. This is especially like if you try to fix something that's malfunctioned or broken. So that needs a special permit procedure in order for you to do it. So the permit procedure includes the description of the hazards and the actions taken to prevent the accident. Let's say you have a leak in a pipeline. So it doesn't happen every day. It just happened at that time. So you need to fix that leak. In order for you to fix that leak, to work on it, you need a special permit on it. That permit, you have to describe what are the hazards of going there and fixing that leak, and what are actions that you must take if something bad happens. Okay, because it's a leak, it's hazardous, anything happen, it has to be properly documented. And that formal permits, it communicates all the relevant information between the people who's doing that job and the other operating personnel who can be affected by that work. Because of course, when you fix that leak, there are people around you who's doing their daily job. So so that you communicate and tell them that I'm doing this. Okay, you guys should be careful because you guys are here. You must be aware that this is happening. Okay, for example, if I'm fixing that leak, I have to shut that section of the pipe, making sure that there are no gases or no fluids flowing through it while I'm doing the job. So I have to shut it, isolate that part of the pipe. And the other people must know this. I isolate this because I'm fixing it. So don't try to open the line and put liquid or put a flow in it. Okay, so that's why you need to have that permit and tell people that this work is being done. Okay. Okay, so now work permit. Work permit is a written form that's used to authorize the jobs that endanger workers to the serious hazards. So it recognizes what is the work to be done, what are the hazards involved, and what are the necessary preparation and precautions for the job. Examples of jobs that need work permits is if you're working in confined space. Let's say you are maintaining a vessel, you need to go into the vessel or go into a manhole. You need permit to do that. You cannot just simply go down a manhole and do your work in there. And repair work, like I said, to fix a leaking pipe, okay, you need to repair something, or even changing a light bulb in an office space, okay. And maintenance work, or you're doing an inspection of electrical installations, or when you are starting to use a complex equipment. So those things needs work permit because it serves as a record of authorization as well as the completion of that specific work, and the authorization must be provided by the competent person after all of the necessary conditions have been met. And then there are many different types of permits. There's the hot work permit, there's CoWork permit, there is the confined space permit, electrical permit, excavation permit, radiation permit. There's so many different kinds of permit, very specific to the type of work that's been done. Okay. Okay, so the first type of permit is hot work permit. So hot work permit is actually permit that must be given when the job involves doing something hot, okay, such as welding operations, or you're using a torch, for example, ignition of flammable and combustible gases and liquids. So to do those things, you need a hot work permit. Okay, so what is hot work? So hot work is described as cutting and welding operations for constructions and demolition activities, and it involves the use of portable gases or arc welding, or torch cutting, and also when you do soldering, you do grinding, or any other similar activities that produces sparks, it produces flame, or use heat. So you need to have this hot work permit. So when you do it, you're doing a hot work permit. You will have this kind of tag. Okay, it says hot work permit, and then you write there what is the area of the hot work, what are the works to be done, and then you put it at the location where you do it. And then it says there, do not remove the tag. Okay. Because it serves as a warning that there's hot work being done there. Now, another type of work permit is called a cold work permit. So a cold work permit, it covers potentially any kinds of hazardous activities that's not covered by the hot work permit. Some examples include when you do chemical cleaning. When you do chemical cleaning, you use solvents that are very volatile. You need to have a cold work permit. And then if you're handling hazardous substances that are toxic, that are corrosive, asbestos, for example, so those need cold work permit. And the use of resins is typically used during blade repairs. Any paint jobs, if doing paint jobs, you need to have a cold work permit. If you're doing any heavy lifts, this refers to crane and lifting procedures. And then also, if you're erecting or dismantling scaffolds, this is in the construction industry. Any non-routine and potentially hazardous activities, and also any activities that require specific control measures to confirm safety. Okay, that's where you need the CoWork. Another type of permit is the confined space permit. So this is also known as the vessel entry permit. So the vessel entry permit, or a confined space permit, it prevents somebody from being injured in a confined space. So it's because you can get suffocated in confined space if there's not enough oxygen. There's a lot of potential injuries in confined space. One of it is you can become overcome by a gas. Suddenly there's a volatile fluid in there. You can become entangled with moving equipment, and you are in a confined space. It's really hard to move, or you being engulfed by any gases or liquids that enters. That's why when you are in a confined space, you have to have this permit, and you have to put these warning signs to say that there's somebody in there. Don't put any kinds of gases or liquid in there. You don't want to drown that person, or don't create any fire or sparks around it because there's somebody in there. Okay? So this confined space, examples of confined space are chambers, tanks, and tanks are sealed and open top. It can be vessels, furnaces, ducts, sewers, manholes, pits, flues, excavations, boilers, reactors, oven. Okay, so these are examples. I'm not sure if I showed this video before about an accident that occurred because the workers are doing paint job inside a confined space. And when you do a paint job, you have to make sure that they have this gas detector to make sure that, because paints, they are volatile, and that volatile fluid is flammable. If there is sparks nearby, maybe from a short circuit from the electrical line, can cause an explosion in that confined space. So that is dangerous. So this is why you need to have these permits before you have to be knowledgeable and know what are the consequences, what are the types of hazards that can happen in the confined space before you can do the job. Okay, so there's also the lockout tagout safety, LOTO, the LOTO. The LOTO prevents injuries or damage due to accidental release of stored energy from equipment. This must be used on electrical, gravitational, mechanical, or thermal, and it prevents the equipment under the maintenance to be unexpectedly set in motion and endangering the worker. Okay, like I said just now, you put the tag there to say that do not open this valve. Never ever, because a maintenance job is being done elsewhere that is connected to that line. Because people might not see that person working, because sometimes that valve can be far away from where the maintenance job is being done. People don't know that it's being shut off because somebody's working at the other side of the area. You don't want somebody going there and then see it. Hey, why is this valve shut off? It should be open, and then it's just trying to be nice, I guess. Turns on that valve, and then causes injuries to the person who's doing the maintenance work at the other side of that building, maybe, for example. Okay, so you do this. Lock out and tag out for safety because you want to isolate potential energy sources, okay, or potential hazard that can happen to the person who's doing the work. Okay, so whenever you do a lock out and tag out, the procedure is first you have to identify what are the types of energy source that's being used and what are the potential hazards and all control devices, and then you have to notify everybody, notify all the employees that this is being done. You then turn off all of the operating controls, and you isolate. So you isolate just that area. You don't want to have any flows in it. You don't want any electrical current going through it. Okay, so you isolate just that area, and then you lock out the switch. When you have the switch, you lock it so that people cannot open it or cannot operate it. And then before you do that, you also test if that LOTO system works. And then you do your task. Once it's done, then you can remove that lockout device. Okay, only after the equipment is fully assembled and all the affected employees have been notified, and then all the lockout devices must be removed by the same person who put it on. And that is all on the safety procedures. Thank you very much. That's the end of the presentation. Any questions?